Hi, welcome back. I guess you've seen the first part. If you haven't, you might want to watch that first. Otherwise, this probably wouldn't make any sense. In this second video, we'll talk about two things. We'll talk a little bit about the wiring, how it's wired, and what an FTDI chip is, and then we'll go dive into the code. So this is the FTDI module that I got from SparkFun. I have the 3.3 volt version, and I bought it because this one here. And when I bought it, it has a different wiring. It has a plug like this one. I don't know if they removed these pins now or what, but it doesn't really matter which one you buy because we're not really using the power output. Basically, its purpose is to be able to do serial communication through the USB port, because these days computers don't really have an RS-232 port, and also an RS-232 port has a, I believe, 12 volt data input and output, whereas Netduino or an Arduino only have 3.3 or 5 volts. So it allows you to communicate using very low voltage serially through the USB cable instead of going through a real RS-232. But when you plug one of these modules in, it actually appears as a COM port. So you can use a terminal program, or you can connect this to a serial device like an LCD or some other serial device. Card reader probably is also serial. But anyway, as you can see, I only have 3 wires here. So this is a common ground that is connected in here, such that these signals have a common ground with the Netduino. And the other 2 is the read and write, transmit and receive pins. So on the Netduino side, we have D0, and I connect that D0 to the TX pin, the TXO pin on the FTDI chip, and that talks to the computer on COM4. And the other one is the TX pin, which is the D1, and that goes the same way, except the opposite direction. So those are the only 2 wires really, other than the common ground. So that's very simple wiring, and using this you can talk to a computer like I do, or talk to an LCD like I said before. So that's the wiring. Now as far as the code, everything actually is pretty simple, and if you only want to deal with single character, you basically have a few lines of code. But I want it such that you can type an actual sentence, an on, like turn on, or basically a more complicated input and output. And that's what this helper class does. And we'll get back to that. So first, let's still look at the main program. The first thing it does is instantiate my helper class, which we'll go into. And then I set up a button. There's nothing interesting in here. I won't even go in here. Basically, it sets up this button and that LED, and then this guy here will be called when the button is pressed. It's going to call this, and that's the one that actually prints that. So that one's easy. The output is easy because it simply calls printline, and printline is one of the methods I have in the helper, which basically outputs a string. No big deal. The one that's more interesting is to be able to do a read line, because the built-in serial port can read one character at a time, but it cannot do a read line. That's what the helper does help us with. So this basically sets up the IO, sits in here forever, calling read line forever, and basically as long as there's nothing, as long as the length is 0, then it just keeps on going. When the length is more than 0, then it checks to see if it is contains the word on. And if it starts with the word on, it turns a light on, because this expression will become true. And if it doesn't start with the word on, this expression will become false and the LED will turn off. So that's that. So let's go to read line. Okay, read line. Oh, we probably should set up the port first. So when we instantiate the class over here, it of course runs the constructor over here, and here is the actual class that comes with the Netduino SerialPort, and I just pass in everything verbatim. Whatever the input comes in this case nothing. I have some defaults in here, so if they say nothing, that means use COM1. If they don't say the baud rate, use 9600, etc, etc. So those are just the defaults, so that way you can easily say go use the serial port and it will default to those values. But you can put in those parameters, of course, to override them. And then for some reason the default timeout is -1, so I set it to 10 milliseconds. And then this is the data received handler. So whenever there's data, it's actually going to call this function. And this is where things get interesting. So the data is going to come in, and we don't know how many characters actually going to be. It may be 1 character, maybe 16 character, depends on the speed and how fast it's being sent by the sender. And basically I say go read as much as you can. The buffer max is set currently as 1K, but I increment this buffer length with the, well, I'm jumping ahead here. So let's just say, okay, I'm just going to read at max 1K with the offset of buffer length, which is currently 0. So it's going to put it at a character 0, potentially 1,000 characters. And then it will return how many characters it actually read. And typically if I'm typing this, it will actually be 1 because it's fast enough to see me pause between the O and the N. So it received first character. Now the buffer is 1 character long, and it's still not too long, so it's okay. And basically it's this buffer is now, which is an array, on the zeros element it contains my first character. And that's all that this does. And it just wait until somebody called the read line. Remember, we call this read line. So when somebody called the read line, it looks at the length of the buffer, which we increment, so it's actually 1 now, and it looks at the every single character in that buffer. As long as there is no carriage return or a line feed, then we don't do anything. We just keep on going, and readline will return a blank string. But as soon as there is a return, we say, hey, turn that return character into a string terminator, and then go grab whatever is in that buffer, which will be terminated right here, and concatenate it with this line string. The reason that I have this blank here is because if we are trying to read 0 byte, this return a null. And if we leave that to be null, the people outside will have to check for null, blah blah blah. And rather than dealing with that, I always just say concatenate with a blank string, which is different than null. And so that way nobody who calls this have to deal with the null string. And then I print the debug, and then I increment the buffer length. Actually, I decrement the buffer length such that it's actually whatever is left over past where we see that return. And then I copy over whatever is at the location after we find the return. So this is the I is where we find the return. So skip that character by 1 character, copy that to the beginning of the buffer. So this is the target, this is the source of the copy, and this is how many characters to copy. And that will basically shift everything to the beginning of the line. Shifts everything to begin to the buffer, and we're now ready to concatenate that again. There is a bug here which I need somebody's help with threading and stuff, but since we're going slow enough, it doesn't seem to be a problem. But if potentially while we're doing this, the buffer length or the buffer changes, there will be a bug in here and we will lose characters. But since I'm just typing it or sending it from a LCD serial port or something, it's slow enough. I think it won't be a problem for now. But that's about that. And the other one is very easy. Just to go get the line, which is a string type. We need to actually, before we send it, this wants an array of bytes. So you have to use the encoder class, the encoding class, and tell it to convert that string into a byte array, and then send the byte array through this serial port. And this one is simply a helper that just simply adds a return. And that is everything, I believe. If you guys have any question, put a comment. Thank you very much. Bye bye.